what's known as the plenum. Now, usually the plenum is thought of as any space above this drop ceiling. So maybe this empty space up here, or down here we have a raised floor, right? We might have cabling running underneath the floor. You find that very often in server rooms. Number one, because you have a lot of cabling, and number two, sometimes we'll raise the floor because those server rooms are on the first floor of a building, or even the basement of a building, and you may get some water and you may get a flood, so you raise the room up to help protect some of your equipment against that. But anyway, very often the plenum is thought of as these hidden spaces. Well, actually, I will tell you that although technically they may not be the plenum, you may want to use plenum grade cable in those empty spaces. And the reason why is because, if we go back to our drawing here, let me clear this out. Even though we may have designated space for airflow, what you may not realize is, well, maybe, over time or whatever, maybe there's a hole that has formed in the duct. I mean, that happens all the time. And then what ends up happening is air from this open space here leaks into that ductwork. Now, you might be thinking to yourself, wait a minute, Ed, so what? What does this all mean? Why do we care? Well, the reason we care is because your typical non-plenum grade cable uses polyvinyl chloride, or PVC, as the outer shielding on the cable. And PVC, if it were to catch on fire, melts and gives off toxic fumes. Aha! Now we start to understand. We don't want these toxic fumes to spread around and make people sick or possibly kill them. So they make a grade of cable called plenum grade, where the outer shielding on the cable is made of a material that, if it were to get hot or catch on fire, it would disintegrate to a harmless powder. I can also tell you that standard cabling sometimes can help spread the fire. Sometimes a fire can actually spread along the cable, whereas again, with plenum grade cable, it disintegrates quickly into a powder and therefore helps prevent the spread of the fire. So, if you're confused, let me give you the real easy way to understand it. If you are going to have cable that is hidden in some enclosed space, either above the drop ceiling, below a raised floor, or I'll tell you what, sometimes you even end up, don't have a very straight line there. Here, make another shot at it here. Boom, there you go. You got channeling going along the wall. So maybe this is hidden behind a wall. Well, if you have cables in there, well, then you are going to want to use plenum grade cable. Now, another way that you can avoid this, because you might be thinking, well, plenum is more expensive, and yes, it is. The way you can avoid using plenum grade cable and still staying within fire code is you can run your cables through some form of conduit. Okay, that would be another way to make sure that you are safe if these cables were to run through a pipe. Alright, so now we've learned all about the different types of cable, right? We have our twisted pair, we have our coaxial, we have our fiber optic, and then we also have our plenum grade that we might have to worry about. Well, now that we know about the cables, what about the connectors? Alright, well, here are some of the common connectors that are used in today's networks. Well, first of all, we have the most common form out there, RJ45. RJ45 is used on twisted pair cabling. And when we were talking about twisted pair cabling, we talked about the RJ45. I said that it looked a lot like the typical telephone cable connector. Well, there it is. Right? There's your typical telephone cable with the RJ11 connector. And again, you'll notice it's very similar. Matter of fact, this extra protective rubber right here that you see on this little jacket is not always there. That's just this particular cable that I have a picture of. Okay, so the reality is that these two connectors look almost identical. Matter of fact, because these two pictures are not drawn to proportion, they look almost perfectly identical. The reality, though, is that the RJ11 does not have as many connections as the RJ45. See, the RJ45 is designed, and if you look real closely here, you'll see that there are 8 connectors there, whereas the RJ11 only has 6. And if you're real quick thinking, wait a minute, 6? I thought it was 4. Yes, it is true that telephone wire only uses 4 of the 6 connectors on the RJ11 connector. Okay, so RJ45 is what you will see in twisted pair cabling, but I wanted to show you RJ11 because that is kind of its little sister. Now here we have the BNC connector, right? We saw that with our thin net coaxial cabling. And then I mentioned RG59 or RG6, and this is probably a somewhat familiar looking cable, and that's because this is what you'll find on the back of your television, going out to the cable company or satellite, or maybe even up to a roof antenna, however you might be connected. But this up here is the type you would find in computer networking. And then here we have our 3 fiber optic connectors, which we were just looking at a few minutes ago, our SC, ST, and LC connectors. And again, I don't want you to worry about the actual specifications of these right now. Basically, I want you to know what they look like so that you could point them out if you were to either on a certification exam be asked a question, or if maybe somebody were to hand you a cable and say, what is this? And you can say, oh, that's fiber optic with an ST connector. Beyond that, unless you're going to be an actual fiber cabling specialist, that's all you really need to know. Now, there is one more type of connector I want to show you here. And it's right down here, and I've actually showed you the entire cable. This is an RS-232 serial cable. Now, serial cable is mentioned in the objectives for the Network Plus exam. So there's always a chance you might get a question about it. But typically, serial cables are not used anymore for any type of network communication other than maybe connecting into certain networking devices. You might still have the serial cable connection to plug in a monitor onto certain network devices, but even that has moved over into USB cables. So just on the chance that you get asked a question, an RS-232 connector, which are these connectors that you see here, and it's kind of hard to see, but that's what's called a female connector because it's solid and has holes in it. And then here we have the male version of the connector, which is where it goes around the outside, and there are 9 pins in there. The RS-232 connector is on the serial cable, and serial cable means just that. It means data travels in serial fashion, 1 bit at a time, one right after the other. There's not really anything else I want to go into there. Those cables are not used anymore, but I wanted you to see it in case you get a question on the test. Now let's take a look at some of the different wiring standards. Now here's a couple pictures that you've seen before, right? Here's the open version of a twisted pair cable, and then here's the closed version. Well, although you've seen those 2 pictures before, what we need to talk about is how do we get this to look like that? Okay, the way we terminate a twisted pair cable into the RJ45 jack, and we do so with these 8 wires being, and first of all, we open up the end, so we actually have 8 individual wires, not 4 twists, and stick them into the 8 different connectors. Well, we do that using the EIA TIA standard of 568A or B. And those standards are what specify which colors go into which connectors. So if you were to take the RJ45 connector and you were to hold it flat, and then you take your 8 wires, which up here you'll see these are the green, and then although the other one looks white, it's actually green and white striped. And then we have orange and white stripe, and brown and white striped, and blue and white striped. You'll see that those wires will be put into ports 1 through 8 in this order. The green and white goes into pin number 1, solid green goes into pin number 2, orange and white goes into 3, solid blue into 4, blue and white, orange, brown and white, brown. Okay? That's 568A. Now with 568B, you will see that it's almost the same except for the orange and the green have been inverted. In other words, we start off with orange and white and then go to solid orange, whereas before we had green and white and solid green. And then here for number 3, where we had orange and white before, and number 6 where we had solid orange, now we have for number 3 green and white, and for number 6 solid green. What the heck does that mean, Ed? Let me explain what that means. Basically, those specific ports have to do with our send and receive, okay, or our transmit and receive. And so we've inverted those, and the reason we inverted them for the purposes of creating different types of cabling for different types of connections. And actually, let me move along into that. See, a regular, what's known as straight or straight through cable, has 568A wiring on both ends. And the reason why is because this is the type of cable you would use to go from a computer to one of many different network connection devices like hubs and switches and routers. And these are all kinds of devices we're going to get into later. But basically, if you're going into one of those devices, the port that you plug into is inverted within the device. So we use the same 568A termination on both ends. Whereas a crossover cable has 568A on one end and then 568B on the other. And the reason why is because this would be used to connect one computer to another computer. So as a for instance, if we go back here, let's say, and I don't want you to worry about exactly which wire does what when it comes to communication, but just as a for instance, let's say that the computer network card where this cable's plugged into is expecting to transmit data on pin number 3. Well, the problem you would have is if you had 568A on both ends, when you get to the other computer, well, this same wire is going to be plugged into pin number 3, and that computer is expecting to send on pin 3, not receive on pin 3. So that's where we would then invert it, and pin 3 would now be on the receiving end on a crossover cable, a different wire, so that it can send on one and receive on the other appropriately. So the crossover cable is 568A on one, 568B on the other, and basically what you're doing is you're taking the send and receive and you're inverting them. Now, a third type of cable is something called a rollover cable. Now, a rollover cable is going to have 568A on one end, and then it's going to have a complete reversal of the wires on the other. And what I mean by that is, let me go back to this drawing again. Let me get some of this stuff out of the way. This is how one side would be configured, but then what would happen is for the other side of the cable, you would actually have solid brown here on one, and the reason why is because solid brown is over here. You'd have brown and white over here, then solid orange, then white and blue striped, then solid blue, then orange and white striped, then solid green, and then finally green and white. In other words, you would completely twist the entire cable around. Now, this